Imagine a moment so brief, it escapes comprehension. You're standing under a clear sky, the world normal, until in less than a blink, everything changes. A new sun erupts on the horizon, impossibly bright, erasing all you know. This is not a distant star, it's here on Earth. Its arrival is faster than thought. Before your brain can process the light, it's already over. This is the reality of a nuclear explosion at close range, an event faster than human consciousness. The power unleashed is the energy of the stars, weaponized. Atoms are torn apart, releasing a torrent of energy that defies belief. The air itself becomes fuel, the ground trembles from the force of creation and destruction. For anyone near the epicenter, there's no time to react, no time to feel fear or understand. The event simply happens, you're consumed before your mind registers the end. This is humanity's scientific prowess turned nightmare. Unlike a chemical explosion, a nuclear blast taps into the core of matter. It's both elegant in physics and horrifying in application. The speed of destruction is uniquely terrifying, operating on a timescale our biology can't comprehend. Disasters usually unfold, giving us moments to react. Not here. A nuclear detonation at ground zero is instantaneous erasure. Light, heat, and force arrive in a fraction of a second. You don't see the flash and then feel the heat, you experience everything at once. It's a single, overwhelming wave of energy, ending your existence before your brain can even process what's happening. The ultimate horror. The event is over before you know it began. This is the unthinkable instant. What is a nuclear explosion? It's not just a bigger bomb, it's a different phenomenon. At its core, a nuclear explosion is a chain reaction releasing immense energy from atomic nuclei. Fission splits heavy atoms like uranium or plutonium, releasing energy and more neutrons, creating a runaway chain reaction. Einstein's E = mc2 explains it. A tiny amount of mass becomes a huge amount of energy. In Hiroshima, less than a gram of matter produced a blast equal to 15,000 tons of TNT. Fusion, the other process, combines light atoms like hydrogen into helium, releasing even more energy. Thermonuclear weapons use fission to trigger fusion, creating explosions hundreds of times more powerful than early atomic bombs. A nuclear explosion recreates the conditions of a star's core, right here on Earth. Temperatures reach tens of millions of degrees, everything in the fireball becomes a glowing plasma. This is not a chemical fire, it's matter vaporized, energy unleashed in forms that devastate everything nearby. The unleashed energy radiates outward, each form carrying unimaginable destructive power. A nuclear explosion's destruction comes in three waves: initial radiation, thermal pulse, and blast wave. First, a burst of gamma rays and neutrons, silent, invisible, deadly, arrives almost instantly. Next, the thermal pulse, a blinding flash and searing heat, igniting fires and causing burns over vast areas. At close range, it vaporizes materials in human tissue. The thermal pulse delivers about a third of the explosion's energy, fueling firestorms. Finally, the blast wave, a supersonic wall of compressed air, flattens buildings and hurls debris. The blast wave carries half the explosion's energy, causing massive destruction. For those near the blast, these effects are nearly simultaneous. Radiation, then heat, then the crushing shockwave. The sequence is a multi-layered attack, each effect compounding the devastation. Understanding this trio, radiation, heat, blast, is key to grasping nuclear weapons' unique horror. It's not just one force, but three, arriving in rapid succession. The result, a zone of near-total destruction. This is the anatomy of a nuclear apocalypse. Let's zoom in on the first moments of a nuclear detonation. In the first microsecond, the chain reaction is complete. The core becomes a ball of plasma at tens of millions of degrees. Pressure builds to millions of times normal, radiating X-rays that heat the surrounding air to incandescence. The fireball forms and expands at incredible speed. The initial flash, brighter than anything humans have created, reaches observers first. Light and gamma radiation arrive in microseconds, followed by the thermal pulse. The fireball's surface temperature peaks, sending out a wave of heat that ignites materials miles away. At close range, the heat causes catastrophic flash burns and vaporizes solid matter. Within the first millisecond, lethal radiation and searing heat have already struck. These forces travel at light speed long before any sound or shockwave. The moment is silent, brilliant, and unimaginably hot. It's the birth of a man-made star, pure raw energy unleashed. This instant sets the stage for all the destruction to follow. Now compare this speed to the human brain. Our brains process sensory input in about 100–200 milliseconds, a tenth of a second. Imagine you're 2 kilometers from a nuclear blast. The flash and deadly radiation reach you in under 7 microseconds, thousands of times faster than you can react. You're irradiated and incinerated before your brain even registers the light. By the time you could think, "What is that?" it's already over. The shockwave, though slower, arrives in seconds, still too fast to matter. In the zone of total destruction, the event is finished before your mind can process it. You never hear the explosion or feel the heat, you simply cease to exist. This is the ultimate horror, a weapon faster than thought, collapsing perception into a single instant. There's no time for fear or understanding. The physical event ends before mental awareness begins. In the race between light and consciousness, consciousness always loses. At ground zero, the human body stands no chance. In the first microsecond, gamma rays and neutrons destroy cellular structures and DNA. The radiation dose is so massive it causes instant catastrophic failure of the nervous system. Simultaneously, the thermal pulse vaporizes the body. Water turns to steam, tissues become gas and carbon. Nothing remains. The body is erased, part of the fireball. Even slightly farther away, third-degree burns, flash blindness, and seared lungs mean death is nearly as swift. The shockwave crushes and tears apart anything left. Survival is impossible within the initial zone. The physics of a nuclear explosion simply overwhelm the human body. These aren't just theories. History has shown us the reality. On August 6, 1945, Hiroshima was devastated by a 15-kiloton bomb. Survivors described a blinding flash, the Pika, followed by a thunderous roar, the Dawn. For those closest, there was only the flash, the rest was annihilation. The thermal pulse burned clothing patterns into skin, and at the hypocenter, bodies were vaporized, leaving only shadows on stone. The blast flattened the city, and fires merged into a firestorm. Fallout rained down, poisoning survivors and causing radiation sickness. Hiroshima and Nagasaki moved nuclear weapons from theory to human tragedy. Their legacy is a permanent reminder of the catastrophic power of the atom. The science of nuclear blasts is a story of extremes and precision. Fission bombs use explosives to create a supercritical mass, starting a chain reaction in microseconds. Implosion-type weapons compress plutonium with shaped charges for greater efficiency. Each fission generation takes nanoseconds. In less than a microsecond, the energy release is complete. Only a small fraction of material fissions. Modern weapons are more efficient, and thermonuclear bombs add fusion for even more power. The energy heats air and bomb materials to millions of degrees, forming the fireball and shockwave. The expanding fireball creates a supersonic shockwave, transferring immense kinetic energy outward. Radioactive fallout, leftover fissile material and fission products, contaminates the environment for years. If detonated near the ground, fallout spreads widely, posing a long-term threat. The physics is complex, but the result is simple total devastation. Understanding nuclear explosions is a profound responsibility. Knowing a single weapon can unleash star-like power faster than thought changes our view of conflict and survival. This knowledge isn't to create fear, but respect for the power we've unlocked. Hiroshima and Nagasaki are warnings. These weapons are not abstract, but instruments of unimaginable suffering. It's vital for leaders and societies to prioritize diplomacy and arms control. Education is our best defense. Understanding the science makes us more likely to prevent their use. The difference between conventional and nuclear war is total. In nuclear conflict, there are no winners. This knowledge empowers us to demand accountability and advocate for a safer future. The story of the bomb is about human brilliance and folly, our capacity for discovery and destruction. The future isn't written. Ensuring it's peaceful is up to all of us.